Hi everyone, NinjaBait here, and today I'll be showing you how to create assets for Tabletop Simulator from digital Lego models. The process that we're using is here. First, we're going to generate that model in a program called MechaBricks. Then we're going to export that model to Blender. We're going to retopologize the model in Blender, and we're going to bake textures in Blender. We're going to modify the textures in GIMP if it's needed, and then we're going to load those models into Tabletop Simulator. Very straightforward. This tutorial is assuming that you're familiar with all the programs shown here in terms of selection and navigation and some of the basic use of the program. Except for Tabletop Simulator, all of these programs are free, and links are going to be provided in the description of this video. Out of all the programs, Blender is definitely the one with the steepest learning curve, so I'll link to a great beginner tutorial series in the description. If you can complete the first video in that tutorial series, then you're probably set to run this tutorial as well. But it's a good idea to just go through the whole series and become a bit of a power user in Blender. So we're going to get started in MechaBricks in the workshop. MechaBricks is a web-based Lego designing program or construction brick designing program. And we're going to just create a really basic model here. Just a simple computer console with a couple of 2x2 bricks and then a nice computer console slope on top of it. And let's make all of these bricks blue so it all matches. And there you go. So there's our very basic computer console. What I'm going to do is I'm going to export this so I can bring it into Blender. Under Format, you're looking for the Blender add-on format. So go ahead and export that. That's going to come in just as an untitled model because I didn't save this file. And we're going to try and load this into Blender. The way we're going to do that is by getting the Blender add-on for MechaBricks. Sorry, let me go back a second here. If you aren't that comfortable in MechaBricks doing the Lego designing itself, you can import those files from basically all the popular modeling programs that are out there. But the reason MechaBricks is so important is because of these add-ons. So there's one that you have to pay for. There's one that's free. For the level of detail that we need in Tabletop Simulator, the free version is perfectly acceptable. So you're going to download the zip file that comes with this purchase, and then follow the instructions in the zip file to install that add-on into Blender. So we're going to go over to Blender now, and we're going to delete everything that's in this scene to start. Just by pressing A to select all, and then X to delete. Next, we're going to go to File, Import, and if you've installed the add-on correctly, you'll see that there's a MechaBricks import option. So we're going to do that. We're going to go to our downloads, and we're going to grab the file that we just downloaded, just created. And you can see here that it shows up with the correct color and the correct shape, but none of our texture detail yet, including the decal on the front of this. So we're going to switch over to up here in the upper right-hand corner. You can see there's a bunch of different viewport shading options. And we're going to go over to the third one, which is our material preview. So now you can see this is what the part looks like with all of the textures and materials applied. It's got a bumpy texture, which is, if you're familiar with the bricks themselves, quite familiar. And it's got the nice decal on it, as well as some kind of smaller details like little gaps in between the bricks and all of the interior parts of the brick as well. Let me switch this over to the wireframe view. And in the wireframe view, you can see that each brick is being rendered in its entirety, including the studs and the, as we would call them, anti-studs that are underneath. And in total, this model has 2,550 vertices. So each one of these, each line is connected by 2 vertices. Tabletop Simulator has a hard limit in its programming for each model of 20,000 vertices. For this model, we're well underneath that limit. But in general, it's good to retopologize these models, try and reduce the number of vertices that's in the mesh, so that each model is not taking up too many resources in your system, especially if we want to have 100 of these. We don't want to have to render 2,550 vertices for something that we're going to be looking at, only even just like 100 of those vertices are important. So we're going to begin retopologizing this model. Let me switch back over to our solid view, and we're going to add a new mesh. So hit Shift A, and then go to Mesh, and then go to Cube. And you can see this cube is really small, and that's because there's a unit disagreement between Mechabricks and Blender, and then later on in Tabletop Simulator. The best thing we can do to fix this is to scale down our Lego object ahead of time. So if you select up here in the, what is this thing called? The outliner. If you select the empty that came from our Mechabricks model, we can transform this empty, and all of the parts that came with the Mechabricks model will get transformed with the empty. So I'm going to scale this down from millimeters to inches by dividing by 25.4. And then I'm just going to copy that result and paste it into each of my scales. And if we zoom in now, you can hit home to quickly zoom in. We can see that this computer console is now much closer to the size of our default cube size. All right, let's make this cube look like a computer console. So we're going to select the cube, we're going to hit Tab, and that's going to bring us into edit mode. You can see that now we see little knobs on each of the vertices in this cube. You can also see in the information down here that a cube has 8 vertices. If you remember anything from your geometry classes, you know that that's 100% true. So let's start doing some basic modeling. We're going to hit 7 on the numpad, which will bring us into a orthographic top view. And we're going to select A to select all the vertices in this cube. And then we're going to hit S to scale that cube down. And we're going to get as close to the size of the Mechabricks model as possible, but preferably a little bit bigger. Next, we're going to go over to a side view. And we're going to drag this guy up by pressing G and then Z to limit to the Z direction. We're going to drag it up until just before the bottom of the part. And you can kind of see that when the bottom of the part kind of just disappears. There we go. So what we're going to do is we're going to take the top row of vertices from this model, and we're going to bring it up to the top edge, or the bottom edge, right here where the brick begins to slope. To select the 4 vertices here, we could just go around the model and select each one, or I can hit Shift Z to go into my wireframe mode, then I can hit B to go into box selection, and I can box select the 4 vertices that form the top of the cube. I'm going to go back into my side view. I'm going to zoom in a little bit here. And I'm going to bring this set of vertices up to that corner by hitting G and then Z again to lock our movement in the Z direction. And we're going to bring that up just above where that corner is. The next thing I'm going to do is I'm going to get up to the top of the slope. So to do that, I'm going to hit E to extrude, and then I can hit Z to lock it to the Z direction. And I'm just going to bring that right up to the top of the slope. The next thing we want to do is we want to bring these corners in to match the slope itself. So again, I can hit B to box select, and this will select through the part. And I can hit G, and then I can hit, I believe it'll be Y. So that locks us to the Y axis. And we can get really close to the slope. If we switch back to our solid view, you can see now that we've covered up all the insides of the brick with just simple faces. We have now only 12 vertices where we once were going to have 2,550. Let's do a little bit more cleanup on this block before we go and make our studs. You can see here that this vertex and this vertex don't serve a purpose in the geometry of the part. They don't correspond to a true corner on the part. So what we're going to do is we're going to merge this with one of the corners of the part. So you select the unwanted vertex and then one of your corner vertices, and then you hit Alt-M to merge. And we're going to merge it at the last thing we selected. We're going to do that again for the other side. Now you can see that we've got just 10 vertices to describe the main block of this computer console. Another thing that's worth noting here is that each of the faces of this part have either 4 sides or 3 sides. Nothing has more than 4 sides. And that's because in Tabletop Simulator, it'll only handle what are called quads and tris. So 4-sided shapes and 3-sided shapes. Let's bring in these studs now. We're going to hit Shift A to add a cylinder. And we're going to click on this Add Cylinder menu to make some adjustments here. First of all, we're going to reduce the number of vertices that go around this stud. I think 12 is a good number. But for a larger model, you might want to go even smaller. The next thing we're going to do is we're going to change the cap fill type. You can see that the top and the bottom of this cylinder are 12-sided polygons. They're dodecagons. And those won't render in Tabletop Simulator. So we're going to switch that to triangle fan. And now you can see the top surface and the bottom surface are formed out of triangles, which will render. We're going to hit this vertex here, and we're going to delete that by hitting X and then selecting vertices. And that's because the bottom of the stud is going to be invisible to the end user. Next, we're going to select the whole cylinder by hovering over one of the vertices of the cylinder and then hitting L to select everything that's linked. We're going to go back into our top view. We're going to go back into our wireframe mode. And we're going to use the transform G to line our stud up with the existing studs. And we can actually adjust the movement here in the movement box. If you know your Lego geometry, you know that it's 8 millimeters, and then we have to convert that into inches. Or rather, sorry, it's 8 millimeters from it's 8 millimeters from one stud to the next. So we have to move this 4 millimeters in the X and then 4 millimeters in the Y to get perfectly centered. So we're going to do 4 divided by 25.4, which is about 1.575. Then we're going to do that again. And now we're perfectly aligned with the Mechabricks stud. Sorry, let me go back into our top view here, and you can see that our centers are perfectly aligned. Let's scale this sucker down until we're of a similar size with the existing stud. And in this case, because we're working with cylinders, it's going to be really hard to get the whole stud inside. So what I kind of do is get it so that sort of half of the vertices on the stud are sticking out and half are inside the circle. Let's switch over to our side view, and you can see that we're not really in the right position here. So let's hit G and then Z again to bring this stud up. We're going to bring it up to the top of the stud, but we're going to leave out the portion that actually says Lego on it. And you can see actually, if you look closely, this we failed to align to the correct ring on the stud. We've aligned to one of these chamfers on the studs on these bricks. So let's go back and we'll fix that. So we've got to align to actually these edges in here. So again, that's just S, and then if you hit Shift Z, that's to scale in the Z plane. So that will scale for us without changing our Z position, as you can see here. And then let's bring up the bottom of this stud close to the top of the brick that we built. So again, we can use a box select to select everything from this view. And we're gonna go GZ again to just bring it, translate it up. We want it to overlap a little bit. The next thing we're gonna do is we're gonna duplicate this stud for the other stud on this brick. So select, you select linked to select everything on that stud, and then hit Shift D to duplicate. If you hit escape, the duplicate will stay where it is. And then we can hit G, and then we can hit X to move it in the X direction. And you can see here we've moved minus whatever, but we have a proper number, so we're going to hit minus 1.15748. And we're going to do that, obviously we're going to do that twice. And now that's perfectly aligned. Let's switch back to our solid view and take a quick look at what we've created. So we've created a very basic mesh that encompasses all the physical details of an assembled computer console without any of the extraneous details that you wouldn't be looking at in Tabletop Simulator. So with only 60 vertices, we're capturing all the relevant information that Mechabricks was producing with 2,500 vertices. And that's great because now we can have dozens of these computer consoles without sucking up a lot of resources in Tabletop Simulator, which is exactly what we want to do. Let's export this and just take a quick look at what we've created. We're going to go to Export OBJ, and we're going to want to select Selection Only. So let's go to, we'll keep everything in my Downloads folder here. So Selection Only, and we're going to select the cube. And we're going to call this Computer. Let's export that object file. And then let's go over to Tabletop Simulator. So we're going to create a single player server in Tabletop Simulator. And we're just going to close this window. We don't really care about any of that. And instead, we're going to create some custom objects by hitting Objects and then Custom. So let's create a custom model. Just right-click on that. And then under Model or Mesh, we're going to bring in the mesh we just created, Computer. And we're going to use the local while we're just doing some tests here. And so this looks, from some angles, pretty good. And from some angles, it looks really weird. And you can see that that the studs have very sharp edges. And so they're kind of ugly. This is because we don't have well-defined smooth groups for our faces. If we go over to Blender again, you can see that everything right now is defined as a sharp corner. I can hide the Mechabricks model, and you can see that every edge is defining a sharp corner, and every face is being shaded flat. If I go to Object, and I click Shade Smooth, now you'll see that all of those corners are sort of disappearing, and everything's getting kind of blended together, which is great when you're talking about cylinders, like the studs. But it's not very good when you're talking about a prismatic object like the rest of the brick. So let's go into let's select this and hit Tab and go into edit mode. And let's change our selection filter from vertices to edges. We're going to select all the edges that should define sharp corners. And we're going to leave out all the edges that either are part of flat faces or should be smoothed out, like the edges of the cylinder. Here's a cool trick that you can do. So if you select the one edge on each of these studs, you can select a loop, an edge loop, and that'll select the tops of these studs. So that will define, we're going to use this to define a sharp corner from the top of the stud to the sides of the stud. And we're going to do the same thing for basically all the other faces on or edges on this block. We're obviously going to skip these diagonals because these are part of one solid face here. And let's see. So we'll just do a quick look around, make sure we got all those edges. And we're going to go edge, mark, sharp. This on its own does not actually turn into information that Tabletop Simulator sees. So we're going to add a modifier to this cube. We're going to go to the modifier tab, which is the little wrench, and we're going to add a edge split modifier. And you can see already that it's doing something to this part. It went from that weird blended shading back to the original sharp shading that we had. But that's not quite what we want. It's using something called edge angle, which is sort of a calculated way to split everything. And then it's also using our sharp edges method, which is all the edges that we just marked. And because it's doing both, it's actually cleaning up all of our cylinders as well. So if we just uncheck edge angle, the cylinders will get shaded smooth. Let's export this again and just see what that looks like. Whoops, sorry, I hit import there. Let's export the OBJ file. Let's call this computer sharp. And we're going to stick with selection only. And under geometry, let's make it another selection. So we're applying the modifier, that, and we're also going to want to keep our smooth groups. There's a couple of other options here that we'll talk about as we go, but one of them that's worth noting is triangulate faces. If you've screwed up and you can't figure out which faces are no longer tris and quads, you can check this button, and the exported result should render correctly in Tabletop Simulator because all the faces will be turned into triangles. Let's export that guy. Okay, now I can just select this guy, copy, paste him, and then right-click and adjust his custom settings and change what file he's pointing to. Let's import that. And we don't want to update all the matching objects, so let's hit cancel. And you can see now that we've got great sharp shading on all the prismatic faces. And we've got nice smooth shading on the cylinders of the studs. Let's start working on bringing in all the color information that will make this look like an interesting computer console in Tabletop Simulator. The first thing we're going to do is we're going to switch our view. So right now we're in the layout view. Let's switch over to UV editing. You can see here that we're already in edit mode on this cube. And there's this new window here with a weird little grid on it. What we have to do is unwrap this part so that we can create a texture that Tabletop Simulator will use to render all the color onto the part. Let's start by creating a new image, and we can call this our bake target because we will be baking textures to this part. And we can make this pretty small because this is a relatively simple part. So 512 by 512 should do the job. We don't need an alpha channel for this part because there's no transparent elements. And we can just leave it as a black part, a black image. So there you go. So it creates a black image here. If we go back to the window here, the viewport here, and we select everything, we can see some stuff that we recognize and a lot of stuff that doesn't make sense. You can see this circle is sort of the same as the top of one of these studs. And then there's all these extra lines, things that look sort of like cubes but aren't. And that's the current UV map. And that's going to be very difficult for us to bake to. So we're going to go and we're going to do a smart UV project. We're going to leave angle limit at default, but we're going to add an island margin of 0.05. And then we're just going to hit OK. And now you can see this is something much more recognizable. The wheels look right. This is each stud. These are the clear faces of each of the sides of the cube. And basically, it's rare that you would ever have to go in and manually adjust this for one of these projects, but you could if you wanted to. For example, if you look at, we'll switch to face select mode, and if you selected this face, you can see that this face is squished. It's the same size as this one. So if you really wanted to, if you wanted to capture more detail on our printed slope, you could make this part of the UV map bigger, but we're not going to bother with that. That's extra work. What we're going to do instead is we're going to bring up a new viewport. So we'll just leave this one as our image, and we're going to bring in a shader editor. And we're going to create a new material for our object. Everything in here that you see here is useless to us. We're going to select all, and we're just going to delete it. We're going to add a new texture here called an image texture, and we're going to point it to our bake target. This is going to tell the renderer in Blender, when you render out this part, I want you to put the output on bake target, and I want you to match it to the UV map that goes with this mesh. All right, so we're going to switch back into object mode. We're going to unhide our untitled model, which is our Mechabricks model, and we're going to start looking at our render settings. The first thing we're going to do is we're going to switch our render engine from Eevee to Cycles. We're also going to switch our device from CPU to GPU compute. This may not be an option for you. This is only if you have a dedicated video card. We're going to leave all these settings default for now. We're going to skip straight ahead to baking the texture. The first kind of bake that we're going to do is called a combined bake. And that is all of the color and light information in this scene from parts that we select that gets baked into this bake target. We're going to use selected to active, which means we select the Mechabricks parts and then make the output on our retopologized mesh, our cube. And we're going to make some other quick adjustments here. We're going to make the margin a lot smaller because our texture is not that big. And we're going to leave clear image checked. So let's just do a bake and see what that looks like. So we're going to grab the 3 Mechabricks parts. We're going to grab our cube, and it's important to grab the cube last so that is the active element. And then we're just going to hit bake. What baking is doing is it's rendering each component that we've selected from the Mechabricks model and drawing rays from that model to mesh that we've created around it. So any color and lighting information that you would normally see on the detailed Mechabricks model is going to get projected onto our baked target according to the UV map for the mesh. When it's in the progress bar, you're going to see it go from 0 to 100 3 times because we have 3 parts that it has to do this for in Mechabricks. Okay, so that took about 3.5 minutes. We have our render here, and you can see it's very, very dark. And that's because we didn't bring in particularly good lighting for this scene. Let's fix that. We're going to go over here to the World tab, or the Scene tab, and we're going to change the background up a little bit. Under Color, we're going to click the circle, and we're going to switch to an Environment texture. And we're going to open up a nice environment. I'm using this thing called Studio Small 4K from a website called HDRI Haven. You can find a link for that in the description. These are fantastic free HDR images that you can use to generate some lighting information. And actually, if we switch over to our last button up here, which is the rendered viewport, you can see what that scene looks like. It looks like a big, well-lit studio, which is fantastic for illuminating our part. Right now you can't see anything because the cube that we created is in the way. If we just hide that, you can see this is a really nice, bright blue now. And it's going to come out much better than the very dark blue that we had before. Let's clean this up a little bit by reducing the strength. This is much brighter than the kind of true blue that you would see on a Lego brick. Let's try bringing that down to just half. Let's see how dark that is. You can see that that's still really washing out the colors. So let's bring it down even further. Let's bring it down to maybe 0.25. Okay, and that brings in kind of a good balance of blue, I think. So we're just going to swing back over to our render tab. And because we still have everything selected, I'm just going to unhide the cube. And we're going to hit bake again. And with my computer, I have to switch out of the rendered mode to save some graphical resources. So let's just let it bake. Okay, so here's our new texture. And you can see this is a lot brighter, a lot better color information. And let's just bring this into Tabletop Simulator and see what this looks like. So save this image as, let's call it computer combined. Save as image. And let's of course re-export our cube now so that we have all the latest information from the UV map. We'll call this computer UV. And we'll go back into our geometry tab here and make sure that include UV is selected. And then pop back over to Tabletop Simulator. Let's copy and paste this model and create and adjust the settings here. We'll use our new computer UV object, again local, and we'll use our new, hello, where did it go? So obviously we saved the picture in the wrong location, so let's try that again. We saved it in documents, not downloads. Let's save it over here. There we go. Now it will show up. Computer combined. And we're saving that as the diffuse or image texture. We're not going to update matching objects. So there you go. You can see that this has actually come out a little bit dark. So I think we'll bring the lighting back up to 0.5. And you can also see that the lighting is very noisy. You can see all these bright speckles and you can see sort of individual pixels in the model. So we're going to go and we're going to fix that. Let's switch back to our rendered view and let's hide the retopologized cube. Let's start by reducing or brightening up our background again a little bit to 0.5. And then let's go and let's mess with our render settings first. So the first thing we can do is we can increase the number of samples that we take. Right now it's set to 128. I like to go all the way up to 512 for my final models. And we can, we don't need to look at advanced. We can also look at light paths. So let's leave the max bounces at the levels, at the defaults for now. But let's start applying, first we'll apply clamping. So clamping limits what the brightest bright spots are allowed to be. So let's start by putting in a level, let's just put in 1, and let's see what that does. And you can see that's removed all the bright spots already. But that's not quite realistic for a Lego model, right? You can see this sort of looks almost satiny in its quality. So plastic is a little bit shiny. So let's bring it up a little bit. Let's go all the way up to maybe 3. No, even that's a little bit low. How about 5? All right, now you can see some of the bright spots coming in again on the corners. The other thing we can do is we can uncheck reflective and refractive caustics. And let's see if we bring the direct light caustics all the way up to 10, how bad that will be. Okay, I like that. I like the little bit of shine on the plastic. The other problem that's really happening here is that the textures from Mecha Bricks are a little too detailed. So if we zoomed in, right, you remember that there's a lot of bumpiness to these bricks. And each one of those bumps is creating a bright spot on it. In Tabletop Simulator, the style is a little bit more cartoonish. And so if we allow it to have all these little bumps, it's going to look too realistic. And it's going to look really noisy. So let's go into each part and start adjusting the material a little bit to get rid of that bumpy texture. So we're going to click on the part, and we're going to go over here to our shader editor. And let's see where... Let's actually get out of this for a second. This is slowing my computer down. Embarrassing. There you go. So there's our shader. So you can see that there's a thing here called a normal map. And that's what's creating the bumpiness in the part. So if I remove the normal map, we should see that part now look a lot smoother. So right now that's applied to the bottom brick here. The effect is not as apparent on these 2x2 bricks, I think. So let's go all the way over to our top brick, and let's disconnect the normal nodes for both the decoration and for the base brick. And now you can see, yeah, now you can see this is a lot smoother. You've gotten rid of a bunch of bright spots that are normally visible. Let's render this out and see how this looks now. So we're going to select all those parts again. We're going to select our cube, make sure that it's not hidden. And we're going to, okay, select the cube again. And we're going to do some more things to improve our performance here. So sampling is going to increase the amount of time that it's going to take to render. We can remove hair because we're not rendering any hair. And we can adjust our performance. If you're using a graphics card, you can increase the size of the tiles, and that will usually render a lot faster for a graphics card. For a CPU, you want to have those tiles actually pretty small. All right, let's hit bake, and we'll wait and see what happens. Here we go. So this is our new render, and you can see already from this view that we've improved the quality of the render quite a lot by reducing the bumpiness. So it's a lot less noisy, a lot smoother in appearance. Let's bring that into Tabletop Simulator. Oops, let's save this as combined material edit. And let's bring that into Tabletop Simulator here under the diffuse or image map. And you can see that looks pretty great. That's a great cartoony kind of render of the brick, and it looks good in the Tabletop Simulator environment, right? It might not look good in a more realistic game, but it looks good here. There's some additional information that we can add to the textures that we are missing right now. If we flip this over, right, you can see that there's not a lot of definition to the bottom of the brick where you would expect to see the holes and the anti-studs. There's also around the edges of the brick, right, there's not a lot of information showing you the seams in between bricks. So we can create that information by creating a different kind of bake. So we're going to go back into Blender and we're going to create an ambient occlusion bake. And it's worth checking while we're at it. Under the selected to active method, we can set a ray distance in here. Right now we're getting kind of lucky, but if you set your ray distance wrong, you're going to get into trouble. If it's too large or too small, you're going to get results that you don't expect. I find that for the Lego models, when you've scaled them correctly, around 0.001 to 0.005 is what you need. We're just going to hit bake again. This will go a lot more quickly. Ambient occlusion basically generates shadows around the sides of bricks or around the corners um, and in small gaps in meshes to show where shadows are supposed to be. So there you go. So you can see that this is basically a white mesh, but it's got shadow information, particularly around the studs and around the bottoms of the brick. And you can see actually up here where it says Lego, this might not be so good. We might not want that for kind of legal reasons. So let's go and let's make a quick edit to the part. Let's go switch back into our solid view. Let's select our slope here and we'll tab into the edit mode and we will use our linked selection tools. So just hover over each of these letters and hit L, hit Control Z if necessary, hit L for linked to select the text, and then just hit X vertices to delete the text. So let's switch back to object mode and let's just bake that again just to be safe here. Just to stay on the legal side of the line. Okay, so the Lego text is gone. We can save this as a, instead of combined, we're going to save this as ambient occlusion. We're going to do one more type of bake, and that's called a normal texture. Let's just bake this and we'll see what the result is. You can see that this hasn't really done too much here, but it's created some. First of all, it's a false color image, and it's created something that sort of looks like shadow, kind of in the style that you would get from sort of like lighting this, from like flattening out this object, but leaving some small details and then shining a light from one side. So especially around the decoration, you can see some light bump mapping. This step isn't always necessary to capture all the fine detail in a model, but sometimes it's worth it. So you could kind of play that by ear. Let's save that as our normal map. Okay, and then we're going to switch over to GIMP because we've got to combine our shadow map and our um, normal color combined map. So we're going to grab the ambient occlusion, we're going to grab the combined material edit maps, and we're going to open them as layers. We're going to put the ambient occlusion on top of the combined map, and we're just going to use, we're going to switch it from normal mode to multiply. And that will bring all the darkness from the ambient occlusion map and kind of multiply it by the colors that are in the combined material edit. So where we used to not have any shadow around our studs and around the bottom of the brick, we now have very well-defined shadows. While we're in here, we could also denoise this image a little bit by going to Filters, Enhance, Noise Reduction. And I like to set this at about 2. If you set it too high, you'll start to lose detail from your decorations and smaller details. I think 2 is a pretty good balance. So let's hit 2. So with this image, we're going to export it to a PNG file. We're going to call this multiplied. And now let's go over to Tabletop Simulator and see what we've got. So first, let's look at just the ambient occlusion map by itself. So we're going to bring that into the diffuse image node, and we're not going to update any connecting things. And you can compare this model to the model that you get just from the mesh by itself. And you can see here that, first of all, you've got a lot more definition around the studs. So the studs are casting shadow on the brick that they're attached to. And if you flip this over, of course, you see that you have a false shadow on the bottom of the brick where the insides of the brick normally go. Let's do that again. And this time, let's look at the multiplied image. And again, we're just do it for one thing. So you can see, again, the studs are a little bit more defined here because of the shadow. You can see also slightly better definition in the seams on the bricks. And again, of course, if you flip this over, you can see the false bottom of the brick itself. Now let's look at the normal map. If we brought that normal map into our diffuse or image texture slot, it would look very strange because it's a false color map. So let's instead bring that in as a normal bump map. And let's actually get rid of the diffuse image map for a second, just to see what the lighting effect is on its own. And it might be very subtle here. So certainly if you compare this to our very first models, you're not going to see much, right? But you can see that the decoration, the decal, has a little bit of an edge to it. And you can see that there's some weird shading going on around the cylinders. And that's because we didn't match the number of faces on the studs exactly. So this might actually be a case where we don't want the normal map because it just doesn't look like it's adding a lot. But there are cases where you will actually see that it adds a lot for grills or ridged bricks. So let's leave it out. So we're going to consider this sort of our final model. This has our UV map mesh, and it has our multiplied diffuse image. Next, you see that there's an option to bring in a collider. So let's see what that's about. So copy this model, and let's just paste one on top of this model. And you see these two parts are being simulated as solid objects, which makes sense. The tops of the studs here are not interfering with the bottom of this brick, but we all know that Lego works a little differently. So to cheat, we can create a new collider that will allow us to stack these and hide the studs very sneakily. For this very simple part, we can create the collider very easily. So let's select our cube, and we'll go back into edit mode. And let's use a linked selection to duplicate just the main block of this computer console. So Shift D to duplicate, Escape to leave it in the same location, and then hit P to separate your selection. And you can see now it's created a new cube.001. And this is going to be our collider. So let's output that as an object file. So this is computer collider now. And let's see, let's update this guy with our new collider model. And let's import it. And let's actually update the matching object this time so that they'll stack more correctly. And you can see now that this brick, on top of this brick, it's covering up the studs. So let's say I nudge this over a little bit. It would sort of look like I've connected the two bricks together. Or let's say I flipped this around and line them up kind of next to each other. I could bring in a third one that looks like it connects on those four studs pretty neatly. So now this is our final model with a proper model mesh that's pretty low poly compared to the original. It's got a nice texture on it that simulates the detail of the original. We could have brought in a normal or bump map if the design of the model called for it. And of course, I guess I've screwed up here. We can add the collider to it. And then there's some other things that I like to adjust on top of this. First of all, I like to set everything to figurine so that when you pick them up, they flip upright. Now that just helps with like tabletop gaming in general. If you've got an object that you want a minifigure to be able to stand inside, you're going to need to hit non-convex. In this case, it's a very simple thing. But if you have, for example, like a crater or the insides of a building, you're going to need to select non-convex when you create your collider. And then over in material, I like to turn down the specular intensity a little bit to flatten the model a little bit. I think the default setting is a little too shiny, so let's just import that. And there you go. So there's our final computer console in Tabletop Simulator, brought over from an original Lego model designed in Mechabricks. The next tutorial, I'm going to be showing you how to do the same process with a minifigure using a template model that I've put together for your convenience. And then in future tutorials, I think we'll be doing some more complicated models as well. And all of these models are going to be used in the Brick Wars mod that we're developing for Tabletop Simulator. So thanks for watching. I'm NinjaBait, and to see more of this tutorial series, don't forget to subscribe.